All right, so we're going to start on 11.1, which is inference about two proportions. All right. So let's talk about the requirements. Okay. Number one, it needs to come from a simple random sample, and we are assuming independence. Okay. Number two, N1, P1, Q1 has to be greater than or equal to 10, and N2, P2, Q2 has to be greater than or equal to 10. And rule number three, we are assuming it's normally distributed with no outliers. We're also assuming, I'm going to put that as A, B, we're assuming that N1 is greater than 30 and N2 is greater than 30. And we're also assuming that N1 is less than 5% of your population N1, and N2 is less than 5% of the population of N2. Okay? All right.
Wait, sorry, that population?
The capital N is population.
Okay.
The little n is the sample. Okay? All right. So you guys don't have enough z equations. I'm going to give you another one. Okay? So your z equation for two proportions. Now, in the book, here, I'm going to draw it this way. P1 hat minus P2 hat. I'm going to write it this way. I'm going to tell you why it's a little different than what you have in the book or on your formula sheet. Over the square root of P hat times 1 minus P hat times the square root of 1 over N1 plus 1 over N2. Now, in your formula sheet, it's going to have minus P1 minus P2. And you may say, well, why didn't you include that on yours? Okay? And here's why. When you're doing your null hypothesis, okay, so the idea here, in the past you've had a single proportion, okay, equal to a number, like more than 50% or less than 50% or something. With this kind of a two-proportion test, you've got two proportions. So you're assuming that there's no difference between the proportions. So P1 equals P2. Your alternative can be whatever the alternative is. I'm not going to write that down. Just leave that here. But the fact of the matter is, under the null hypothesis, if P1 equals P2, if you subtract them, what does that equal? 0. That equals 0. That's always going to be 0. Which is why I didn't really put it in my equation, because it's always going to be 0. So why? Okay. Technically, it's supposed to be there, but it's always going to be 0. Okay, so when you're doing this and you're looking at your formula sheet, just know that that's always supposed to be 0, because in the null hypothesis, they're equal. The alternative could be one's greater, one's less than, you're not sure which way to go. Yes.
Which p hat are we using in the denominator?
Now, okay, very good question. So your p hat is what we refer to as the pooled estimate. Okay, and I was just getting ready to go there. So good job, Eric, for taking us there. So your pooled estimate is going to be p hat equals x1 plus x2 over n1 plus n2. So that's important as well. Okay. So let's do an example. Okay. So here we go. I want to share. So if I share my screen, all right. So here's my example. Of 2103 patients in the treatment group, 547 had headaches as a side effect. Of 1671 patients in the control group, or the placebo group, 368 had side effects, or headaches, whatever. Headaches as a side effect. Headaches as side effect, whatever, I can't spell. Okay. Is there significant evidence that control group had more headaches? Okay. I'll make that a question. Use alpha equal to 0.05. Okay. So what's the first question when you're doing a hypothesis test? I know we had all spring break to forget. What's the first question you should ask yourself? Is it categorical, quantitative, or regression? And the answer is categorical, because, what'd you say? You either had a headache or you didn't. Okay? All right, that's correct. Now the next question is, which test? And I'm going to narrow it to the 4 types of tests that we're going to do: a z, a t, a chi-square, or an f. So, looking at this problem, what do you think? It's going to be a z test because, okay, so you went the next way. What's that? Am I going to give you the standard deviation? Yes, I am, right here. Okay, remember, on a categorical test, it's not stated in the problem, but you can figure it out. And it's right here in the denominator. Okay? So it's a z test, and it's 2 proportions. Okay? Not 1 proportion, but 2 proportions. Okay? So now the question, step number 3 is find the test statistic. Okay? Which equation do you think I should use? The one I just gave you. Okay? All right. So in this case, I need to figure out P1 hat. I need to figure out P2 hat. I need to figure out P hat. My N1, my N2. I guess that's it. Okay? So your P hat in this case is what? Oh, actually, you know what? We skipped a step, didn't we? When are we supposed to figure out our null or alternative hypothesis? I'll put that down. We need that step here, but we need to find our null and our alternative hypothesis. What's our null and alternative hypothesis? P1 equals P2. And in this case, or better yet, if you want to be more specific, P drug equals P placebo. Okay? And the alternative is there significant headache, especially if you read the drug and the placebo this way, then you know which way you're doing your sign, right? Because so if they say P drug is going to be less than P placebo. Now, could I say P placebo is greater than P drug? Would that be true as well? Yeah, it would. Okay, it doesn't matter. In one case, it's a left-tailed test. The other case, it's a right-tailed test. It doesn't really matter how you're doing this. Okay? So either one of those would be correct. You're just like, how does that? Because it just depends on the order that you put them in. Either of those could be correct. Okay? Yes? You should sit closer. See, now I can't, if I zoom in too far, I can't see everything all on one page. How's that? Is that okay? Okay. All right, so what's P1 hat in this case? Or let's call this P drug. P drug hat. It's 547 divided by 2103. What's P2 hat? 368 divided by 1671. Okay. Now let's look at this. So this is there evidence that the control group had more headaches? Oh, actually, it looks like it's just the opposite. No, it would be the opposite. The control group had fewer headaches. Oh, that's because I wrote the wrong problem. Is there significant that the drug group, that's what it was supposed to say. Okay, now it's better. Okay, I wrote the question down wrong. But I was like, wow, no, that's not true. But okay. So we're looking for the drug group to have more headaches. It does look like the drug group probably had more. Now the question is, when you say 26 versus 22, is that a significant difference? Be like, it's not that big a difference. Okay, we're trying to find that statistically. Yes? Placebo is 368 out of 1671. Okay? All right, so now P hat. What is P hat? So it's going to be your two numerators. So your 368 plus your 547 divided by your 1671 plus your 2103. Does that make sense? Okay. Your N1 is 2103. Your N2 is 1671. Okay. All right, so we're going to do our test statistic. So that's going to be P1 hat minus, oh, I need to do this. Anyway, minus your P2 hat minus 0, right? I need to change this because now we're saying this is greater. Get rid of that. That's what we're saying. Okay? In your denominator, we're doing the square root of P hat times 1 minus P hat. And so that's one part. We're also doing the square root of 1 divided by N1 plus 1 divided by N2. What's that? I missed my 1, thank you. 1. No, I don't want to fix that. Just don't bother me. 1 there. Okay? So I'm going to take my numerator divided by my denominator, which is this times that. Okay? Gives me a value of 2.83. What is 2.83? That's my z-score. What's my next step? Find your p-value, right? And when you're finding your p-value, what's often useful? Drawing a picture. I'm going to draw my picture on the board. What's going on with my picture? What am I drawing a picture of? What? Go on, Lisa?
I mean, if you want to.
Yeah, won't help with the problem though.
Yeah.
What kind of a distribution am I drawing? Normal distribution. What is the mean of my normal distribution? If we're doing a standard normal, it's a 0, right? What did I get? I got 2.83, didn't I? Yeah, 2.839. Okay, I'm doing a right-tailed test. I want this area to the right. Okay, what is Excel going to give me? It's going to give me what's on the left. So 1 minus. Okay, all right, so as I go back here, my p-value is going to be 1 minus norm S dist of that number there. Okay, which gives me 0.002. Okay, what's my next step? Compare to alpha, which is 0.05. My alpha is 0.05. And then I get 2, reject or not. And then what? Reject or not. Who says reject? Let's vote. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Who says do not reject? Who didn't vote? Okay, 2 honest people. All right, so yes, it is reject. Reject the null, and therefore your conclusion is the evidence that drug group has more headaches than placebo group. And we think you get 4% more headaches, right? So 26. So as we look at that p-value, that's a pretty small p-value, right? That's almost A-word territory. Okay? It might be fun to figure out what if it was in the middle, 24%. What would be your type 2 error? But I'll say that for another day. Now, here's the deal. We've only got 5 minutes left. There is another section here. I don't really want to jam through that in five minutes. On dependent samples. So as we go back here to our thing here, we're assuming these are independent. Okay? Now, if it's dependent, you're going to see some sort of a table. It's going to be a 2 by 2 table. Okay? I don't want to jam through that in 5 minutes. I could, but I don't want to. I'll save that for the next test. Okay? So we're not going to finish this whole section, but as far as the homework is concerned, independence is a big deal. Okay? If it's dependent, so the example I was going to do, just so you understand dependence, let's say I wanted to, let's say you got poison ivy, you got it on both arms. And I wanted to know if ointment A worked better than ointment B. So this is worked or bad, this is worked or bad. You're going to fill out a table like this. Since you're the same person, you could put one lotion on one arm, the other lotion on the other arm, and then see if it heals, see which one heals. Okay? So that would be an example of a dependent proportion, because you're going to have a percent healed here, and you're going to have a percent healed here. Okay? So, but you're the same person, so therefore it's got to be it's going to be dependent. It's not going to be independent. Okay? So we'll save that one for next week, I guess. We're only going to do half of this section for this test. Okay?
So it's tomorrow just a review.
So tomorrow will be a review. Could throw that on there. No quiz? No, there will be a quiz. So we're going to do the quiz tomorrow on independent proportions. So the test will be just independent. So when you're looking at your homework, just pay attention to that. We're going to save that. Your homework is going to be easy because you're going to notice there's some sort of a table in there, so you can skip that. Okay? All right. See you all tomorrow.